Okay, so good afternoon or good evening, depending where you are. Welcome to the second meeting called UEF for usage and feedbacks from users for the climate station developed at the GSE. So it's just a brief reminder. This is a short meeting on regular basis, every 2 weeks. And the purpose is to have the feedbacks and to co-construct the climate station together, users and developers. And so we need your feedbacks and we need your comments to improve it. And yeah, and we need also time to explain you what we have integrated into the station and what are all the functionalities, data sets, indices that are proposed into the climate station. So this is the second one. And today we're going to talk about the Jupyter Notebook. And so it's the main presentation, but as we did for the first meeting, in fact, we will give you some introduction and updates of the climate station, very quick, 5 minutes. Then we will go to the presentation of Jupyter Notebook done by our colleague Vijay with questions, if you have questions on that. And then we have an open discussion at the end of the second half almost of the meeting. Will be an open discussion for comments, requests, feedbacks from you for the development of the climate station. So as an update of the climate station, first, it's not for the climate station, but for the communication. You may, I think you have, because you're here, you have received maybe the automatic message thing that you have been added into the Google group. That is much easier for us to manage the members, the change of emails, or adding people in the. It's much easier, and also to share the mailing list to all the developers. So we decided to move to Google Group to simplify the communication. Nevertheless, the meetings will be still with Zoom. So as today, we're going to stay with Zoom for the meetings. And all the documents, meaning the past meeting records and that one, including that one, some documents and other information are shared into our Teams group. So it's a bit complicated. We used several things, but I think we optimized all the system to get to provide all the information you need in the easiest way. I hope it's going to be fine with you to keep that. So basically, here is the draft agenda. Just to give you, I'm sharing now the Teams group. If I close the document, you see that we are currently into the meeting. The Teams group you're in, and you have the previous messages. And if you go to files, you will find some different information. For example, the specification for the servers or the meetings. You have some telco recorded or the UAF. So if I click on it, you have the videos. So you will find the previous meeting 2 weeks ago, and you will have also some different information regarding the agenda of this UAF. This is the agenda of today. We have also the time zone and the status of the climate station in the different RCCs. So all this information are available on Teams, so you can use it. And okay, so we can go back to the document I shared already with you before. This is the program of today's program. So with the different communication. For the update of the climate station, you know that we're going to release the 1.1.1 version. That could be, we could do it during one of the UEF, the third or the fourth, so the next one or the one after, and we're going to spend this time to update your climate station in all RCCs. What there is new inside, we have new portfolio and new data sets. I won't go into details, but I give you some flavors. So basically, we had added new variables from ERA 5, reanalysis from ERA 5. We have also new forecast products from SIS5 ECMWF at daily and sub-daily resolution, so very high resolution data sets. But we have also new forecast products from different seasonal forecasts. not only ECMWF, but also Meteo France. We think about UKMO and so on. But it's only for variable monthly time scale to not having too much data sets. So we have also included already the new forecast product from these models. In the new version, you will have also new functionalities such as the additional libraries for Jupyter Notebook that will be discussed today, and we have also some bugs fixing. So this is the update of the climate station. Of course, during the meeting where we will make the updates to everyone, we will give you more details about what is included. But today is just to give you some update on what we are doing right now. So now I think we can move to the presentation and the use of Jupyter Notebook into the climate station that is already integrated into your climate station, and some concrete examples. So I can give the floor to Vijay. I need to make some. Oh, I need to. Okay, so Vijay, I think you can share your screen.
Yeah. Okay. Hi everyone. Today we will see one of the component of the climate station, that is Jupyter Notebook. So mainly some of the points we are going to discuss in this session is the Jupyter Notebook introduction. So this will facilitate the people who are new to the Jupyter Notebook, who didn't know what it is. So just to give you a general idea what it is, and then how to access it in the climate station, and what is the usage of the Jupyter Notebook within the climate station, and then the list of the libraries, climate station libraries that can be used in the Jupyter Notebook, which will facilitate a list of things. So these are the main topics we will discuss quickly in this chapter, and then we will see some examples which we already prepared in our production climate station. So that is the main goal of today's session. So the introduction is basically the Jupyter Notebook is a very powerful as well as an interactive tool, which is used for the most of the data science project worldwide, and also in specific in the climate station we work with the usage of the climate data, and then how to visualize it and how to process it to derive some indicators. And also top of it, you can also generate reports directly within the Jupyter Notebook. So these are the main objectives of the Jupyter Notebook within the climate station. So basically, as you could see that you can create these kind of charts, reports, and then incorporated with some of the coding part, so that you can just write some of the documentation, as well as you can create some of the functions which automatically generates the bulletin of reports, something automatically, and then that can be saved or shared with some other people for the reporting. So this is the main purpose of the Jupyter Notebook. So basically, we have the markdown file where you can give some the presentation information, then the PyKernel, that is a Python 3 kernel where you can code a bit, and also it gives you a facility that a terminal where you can access some of the local directories within your Jupyter Notebook. So when we say Jupyter Notebook is for each user, each logged in user, a separate environment is created within the climate station. So this can be saved, and then whatever it is a kind of a workspace. So whatever you do within the climate station are stored within that, and then you can reuse it for the future, and also you can share some of the notebooks with other people for reporting. So this is the main usage of the Jupyter Notebook within the climate station. So basically, the Jupyter Notebook looks like this one. I will also show you from the climate station. So once you open it, you have a toolbox with which is normal to a word processor, let's say, but with some of the launchers where you can either use the Python 3 kernel or a text file or the markdown file on or the terminal, where you can also use some of the command line tools available within the ClimStation. So before going into the introduction, I would like to show you um, again the conceptual design of the ClimStation. Why is because in the previous session we discussed about the data acquisition in the first meeting, and later on also some part of the ingestion, and then in the previous meeting we discussed about the data analysis. So today we are going to look at the Jupyter Notebook. So in specific, in order to show you what are the main purpose of the Jupyter Notebook, I try to create a conceptual model where how it can be used. So basically, the Jupyter Notebook can be used for the ClimStation dataset. So basically, to list all the datasets available within the ClimStation, then to do the data analysis, to visualize the data, create time series, so the dashboard. So whatever Christoph explained you in the last meeting can be also done in the Jupyter Notebook, but um, without having the fixed procedure. But you are free to use any Python libraries to plot them, and also to download the results. Very similar to the data analysis tab in the ClimStation. So on top of it, there is also the processing mechanism. So basically, we have some of the native data sets, climate data sets, seasonal forecast, some reanalysis data. But if you want to derive some more indicators, you can make use of the Jupyter Notebooks. So with our already existing libraries, you can derive some of the accumulations of the data, or you can use your own data, then blend your own data with the existing data from the ClimStation. So all these things can be done from the Jupyter Notebook. So on top of it, also similar to the data analysis, the fitness for purpose can be also done directly through the Jupyter Notebook more flexibly. So that is another advantage. And in the future, there will be also some possibility to have some the impact libraries made available, so that you can also do image classification, image segmentation, all these things more flexibly from the Jupyter Notebook. So these are the main objective of the Jupyter Notebook within the ClimStation context. So I hope it's clear, and if the objective is not clear, you can just write your doubts in the comment. So later on we can discuss about it. So moving on to how to use the Jupyter Notebook in the ClimStation is basically first you have to log in. So if you in the previous meeting, we already described that you have to create your own credential, so that it can be used for us to visualize whether you are working. So whatever maps or workspaces you already created can be stored from the ClimStation. So this is very important. So we wanted you to register as a new user and then log in, and then which gives you a possibility to save your maps, graphs, everything within the analysis. On top of the analysis tool, you can also have your own Jupyter workspaces, as I mentioned. So it is very important that you create your own credential within the ClimStation. So same like here, you can register. If you already have a credential, you can input the credential and then log in. Otherwise, you can just register, create your own credential. So once you log in, you will see in this menu bar, you will see the Jupyter Notebook, with which you can open the Jupyter Notebook within the ClimStation. So I will quickly go to the ClimStation in order to show you. So okay, so once you're logged in, from here you can open the Jupyter Notebook. So once you open the Jupyter Notebook, maybe in your case you may not have you may not have any of these libraries which we created. So, but we will share all these created notebooks to you for because it involves some tutorials as well as some of the processing tools which can be reused with just changing the data sets of your interest. So just to give a quick idea, so it has a toolbox where you can save the file or export the notebooks or edit, clear, cut, copy. It's similar to the word processor. On top of it, it also, you can see the kernel. So the kernel is actually a place where you see what are the notebooks are currently running, the performance. So it is necessary that if you are running, keep on using a lot of kernels, and then it can slow down your workspaces. So it is necessary that you have to close the unwanted or unused notebooks after you finish working on it. So this tab gives you a possibility to check the status of the notebooks or the terminals you are working on, and for the unused things you can shut it down using this kernel. So mainly what we will see in the ClimSA Jupyter Notebook is the file browser, where you put the Jupyter Notebook or create a new Jupyter Notebook or the terminal or markdown file, or this kernel where you stop or shut down your unused the Jupyter notebooks. So on top of it, there is also some other plugins that is currently not going to be discussed in this meeting, but on top of it, you will also see if once it is similar to, let's say, a MATLAB or MATLAB or any of the coding interface where the created variables and then the breakpoints are stored, where you can visualize and work with it. So this is a very general view of the Jupyter Notebook, but you can also have specific tutorial for the Jupyter Notebook to learn the detailed information of the Jupyter Notebook. So moving on to the ClimSA Jupyter Notebook, we will give you all these libraries and the notebooks for you, but you can just drag and drop in this column in order to upload these files, or you can also make use of this upload file icon, where you can just take any of the file and then locate the file and then upload in your system. So that is how you can upload the notebooks which we already created and then start using with it. So as I mentioned before, once you open, you will just see these notebooks where you can create a complete new Python 3 kernel from the scratch at the terminal. So you see, you can open one of it, and then if you're already familiar with Python, you can also start working with it by importing some of the basic Python libraries like time, etc. And then you click on it to run. So this is how you use the notebook. Of course, if you are not familiar with Python or any of the programming languages, you can make use of the created libraries already within the ClimSA. So before moving on to the predefined classes in the ClimSA, I would like to also show you the terminal view, where it gives you opportunity to enter in the ClimSA in your workspace, where you can, this workspace is specially created for you, so you can store your data and then also use some of the existing libraries within the ClimSA to visualize the data. So the GDAL, RScript, or CDO can be used within this terminal if you want to work with your data. So you see that you can just drag and drop your data on top of the notebooks. You can also just drag and drop your data. Then from there you can just start working with these data here, and then it gives you a possibility to also visualize sometimes, and then create a new indicator on top of it. So this is how you work with the Jupyter Notebook. So now we already defined some of the notebooks for you, which gives you understanding how it can be used. As you could see that it is not just the coding area, but you can also create a list of reporting mechanism with similar to a Word document. So where you can create a list of bulletins, list of reports points, as well as some coding area. So that can be changed just by, if you see, if I select this area, it is as mentioned as Markdown. Whereas in this area, it is code. So you can, when you create a new kernel, new Python kernel, you can say that whether you want to mark it as a coding part or the markdown part. So if you mark this one as a markdown part, so then you have to just understand how to use it. So you see that with Ash, it's a general, it is a similar, the markdown language is something similar to the HTML page, where you have to understand this simple technique to create your own uh, page. So you see, I create a small text with this hash symbol, which means that it is created as a heading. So when I use it, so you see that it creates as a heading. So similarly, if you go and then check for the uh, markdown, so you will see a list of the guides to use the markdown language. Similar to the HTML, so with which you can easily create your own markdowns in here in order to create a report or any other bulletins. So you can also drag and drop some of the pictures and then make it as a report. So now we are going to see the list of the libraries in order to visualize the data, process the data within the climate station. So basically we have three main libraries, the data set, what you would have seen in here. So the data set, the climate station data set. So on the hierarchy, it's the data set, but in order to understand how to retrieve the data set, we also created a collection where it gives a list of data sets based on the category or the subproduct or um, the product code. So based on that, you can also process the data set using this proc function, which is built on top of CDO, GDAL, ShiPy, NetCDF4, and XArray. So with the help of this, we already did a kind of a wrapper. And then with this proc function, you can quickly, with hourly data, you can convert the hourly data to the daily data or the daily maximum. So all these things can be done with this kind of a proc function. So let's see how you can import these three or four classes within the climate station. So basically, we have a particular a layer where these classes are stored. So it is a very specific Python way of initializing the classes. So you just call from and then put the location of the libraries and then import this particular class. So this data set is a particular Python class available within the climate station, which we define. So that has to be initiated something like this from the location, that is apps, product management data sets, and then you import the class data set. So once you load this data set, you see that once you click on this particular piece of code and then click on the play, it will initiate this particular class. And then if I wanted to see how to use this particular class, I just use the built-in Python function, which is the help, and followed by the data class which you want to visualize, take the help from. So now I already pre-cooked this one, so I put it here and then I just play this one. So you see that it gives the detailed information about this particular class. So how you can initiate this class, and then how you can filter the data, and then how to get the file names, and then how to group the file names. So all these informations are available within this particular class. So in the help menu, so you can understand what are the list of methods available within this particular class, and then what are the arguments which has to be passed in this particular class. So you see that in the previous meeting we saw how to generate these kind of time series profile graph. So these are made available by selecting one particular product. Here it's mentioned as here I selected the ClimSA 10-day average product. So you basically what you do here is you initiate this dataset class, and then you will see that there is a get time series. So you see that you get time series, and then you pass the method what type of aggregation you want to get. In this case, it's a profile mean, and then you pass the region of interest as a WKT. So in the previous meeting, Christoph explained you, in order to create this kind of graph, you just select the area you are interested in, and then this area is here. It is the um, Congo, one of the area in Congo. But in the same way, if you have a WKT of this particular file, you can automatically generate the time series by passing what type of aggregation you want, and then the, the, the bounding box or the geographic coverage where you want to generate the time series for that particular data set. So in the same operation, whatever we showed before can be done using the Jupyter Notebook, using these classes. Of course, I'm trying to explain you some basic things just to make you understand how these things work. And what is the purpose of explaining you all these detailed part of the coding is there are already predefined functionalities available within the Climate Station, which is already serves most of your needs. But if you wanted to do on top of what is not available within the analysis tool, making use of your data to compare whatever data you have within your institution, you can just drag and drop and then make use of it in order to create such graphs also. So you see that there is also in the data set, there is a view file option where uh, you can visualize the data. So selecting the product and then add to the map, one of the functionality which we saw in the previous meetings, just by clicking a couple of steps. So that can be done also through these particular methods available within this class. So similar to this, we have the other class, which is the proc, which is coming from this location, apps processing and proc function, which also lists a number of functionalities to post-process your data set available within the Climate Station or your own data sets, what you drag and drop here in the Jupyter Notebook or in your workspace. So you see that this class has a number of processing libraries or methods. For example, applying the mask, compute the long-term maximum, long-term statistic maximum, long-term average, or uh, convert the hourly data to daily average or hourly data to daily minimum. So all these things can be done once you know what is available within the conversation. So you can generate any kind of process available within these libraries, and then make use of your data or the data available within the conversation to process them. So that is the main use of the Jupyter Notebook, and also you see how you can take help of these libraries. So basically, there are only three particular libraries which I'm explaining you now. That is, one is the collection, the data set, and then the proc function. So the collection is a group of data sets, And then once you know about the particular data set, then you can make use of this particular data set class to retrieve them, visualize it, and then make use of this data set to do post-processing. So basically, these are the three main classes available within the Climate Station. So, do you have any doubts so far? You can write in the chat, I guess. There is no specific doubt so far regarding the Jupyter Notebook. So I will go a bit in order to show you the collection. So we here also I already pre-cooked one of the notebook which explains you about the collection. So the collection is available from this particular location within the Climate Station. So you call this particular library, initiate the library, and take a help how you can initialize this collection. So it gives you understanding how you can use it. So filter the collection based on the category and then the product code. So play it, and then you get a list of collections, list of data set for this particular collection parameters you passed it. In the same way, you can also, without passing any parameters, you can get a list of the data set available within the Climate Station. So currently there is 192 data set which are listed. Of course, you cannot see everything since it is a long list. So in this way, you can understand each of the data set available within the Climate Station. So once you have a list, once you understand what data set you're interested in, you can move on to the next tutorial. There is a data set where you can initiate the data set as I mentioned, take the L, and then also understand for each particular data set, each methods can be viewed. So in this case here, I'm trying to take help for this data set and the particular class that is the view files. So it gives you the understanding how this view file method has to be initiated. So you either pass the file name or you pass the minimum and maximum value or the index. By default, they are already defined. So you can directly just say view file without passing any parameter, and then you can visualize the data set of this class, of this particular data set class. So I already pre-cooked some of them here, and then I can quickly show you all those things. So I initiate this one. So here you see that how I initiate this particular data set, that is Modis SST, SSTJF of this particular version, and then this particular map set from this collection. So I understand one particular data set which I visualize from the collection. I'm going to take the product code, subproduct code, version, and then the map set, and then you just initiate it, and then you can play it in order to visualize the get file name is a method to list all the file names, files available for that particular data set within the Climate Station. So once you know the files, you can make use of these files in order to visualize the data set. So something I also again pre-cooked already is, you see that I try to, from the data set, I try to understand what is the color map to visualize the data set. And then I say view files by passing the minimum and maximum value, because in some cases, the no data is also visualized if you don't pass the minimum and maximum value. So in this case, you pass the minimum and maximum value, and then you visualize the data set using this particular method, view file. So of course, if you don't understand what it is, then you can also use this built-in elf function in order to play it, and then you understand what it is. So I just need to play all these things. Okay, you see, you understand how to use these methods. If you don't understand, you can understand using this particular help function. You understand what are the parameters to be passed, and then how to retrieve the data set. So is it clear? Yeah, any doubts so far? You can write it in the chat. So whatever we saw so far is something similar to what we saw in the previous meeting. What Christoph explained, to visualize the data set, to generate the time series. So everything you can also do from the from the Jupyter Notebook. So that is what I'm explaining, and how to use these methods. Something I explained. So we will pass on all these tutorials notebooks. So once you log in, you can drag and drop these notebooks in your Jupyter Notebook, and then you can understand better how to use them. So if it is clear, I would like to also show you the other functionality, um, what we saw in the previous meeting, the fitness for purpose. We also, for the fitness for purpose, we saw the scatter plot, Muller, and trend analysis. So all these things can be also done using the Jupyter Notebook. So you see, for the scatter plot, I already created one particular notebook where mm, the similar operation of selecting the data set and then selecting the time period, everything you do it by coding yourself. So you select the data set, you filter the time, you take the files, and then initiate this particular class, the fitness for purpose, and understand how you can initiate. And then you can automatically visualize the scatter plot in the Jupyter Notebook. So something similar what we saw in the previous meeting. So all these things can be created as one particular notebook. We cook up these things already, and then you can make use of it. So and so far we saw about the climate station data set, then the analysis in the Jupyter Notebook, then the fitness for purpose in the Jupyter Notebook. Now we will see how to do the processing in the Jupyter Notebook. So basically, we have a proc function. As I explained before, there is a proc function within the climate station which make use of CDO, GDAL, SHIPI, NetCDF4 XRA in order to post-process the data. So that can be used in order to post-process your data. So similarly, I already pre-cooked some of the helps for this proc function where you apply mask, all these things are already done here. So once you know how to use this file, you can make use of the help for the particular methods, and then start creating your own processing chains in order to derive the indicator. So in this example, I already pre-cooked, I initiated the dataset class proc function. Then I initiated a timesat 10-day product of version 3.1. And then I filtered one particular year. I initiated the proc function. I say, okay, I wanted to compute the accumulation of from 10-day to the monthly data. So I say, okay, I already have the 10-day file. So I initiate the proc function, and then I say compute accumulation, compute accumulation, and then I say the output frequency to be monthly, and then you give output subproduct name, and then automatically it process and then give you back the result of the accumulation. So all these things are pre-cooked. So you just need to, if you want to do the monthly accumulation of rainfall of any of the products, so you can just you make use of this particular library, this particular notebook, and then you initiate the file. It doesn't need to should not necessarily only this particular timestamp, but also other data sets like chirps or something. 10-day product, and then you can just compute the accumulation using these pre-cooked files. pre-cooked notebooks. So this is about the processing. So in the same way, there is also a list of processing which you can make use from the pre-cooked libraries, but you can also create one from the scratch by copying one of the existing notebooks. You can also copy paste whatever you need, and you can create your own chain to derive from hourly to daily, daily to 10-day, or some other SPI. Everything is possible from the Jupyter Notebook by yourself. So the only main important thing is you have to understand what are these proc function and how they are used when making use of this help function. So if this is clear, I can also quickly show some of the graph generations from the seasonal forecast data. You can also initiate so you can drag and drop the data set which you have, and then make use of the libraries available. That is the xarray, matplotlib to plot, and then the numpy in order to read the data set, the seasonal forecast with a multi-dimensional data set. Here there is different ensemble members for a particular total precipitation data. So you can visualize all these graphs. Notebooks are already made available, so you can just make use of it, and then you can generate graphs and bars. So all these things can be done directly. So in the same way, there is also the time series, what we showed in the previous meeting. That can be the time series can be already pre-cooked, so you can just say for what data set you need to create this time series. You just change the product code version, and everything is automatically done for you. So this is about the Jupyter Notebook within the Climate Station. I understand this can be quite complicated for you to grasp everything in a single meeting, but yeah, we will provide all these materials to you, and then you can slowly start looking at these, and then do a hands-on training in your Climate Station. So in order to get familiarized with these the libraries, and then how to use these things. So of course it is not straightforward to do everything in the first day. So everything is available. So if you have some doubts, feel free. I guess I will stop here since it's already I took like more than 20 minutes. Any questions? Any questions? I don't see any question.
I think there is no question for the moment. Thank you, Vijay. It was a bit longer than expected, but I think it deserves, because there is a lot of information, and so yeah. Either you can unmute yourself now. So if you want to ask or a question, or you have any comments regarding the Python, the Jupyter Notebook, sorry, you can just go ahead. And if not, we can also start the open discussion of about the usage and the feedbacks or requests from you. We can start just because Cedric asked from CIMH asked me more information about the brief introduction of the GUI. I think we have a bilateral meeting with CIMH tomorrow, so we will introduce. It's the purpose of the first meetings with the RCC is to introduce you all the functionalities and how it works. So I think it can be the topic of the tomorrow's meeting. if it's fine for you, Cedric. I understand that it's a bit complicated if you just joined the meeting and you didn't have the introduction of all the functionalities. But if there is, I don't know if there is other question, remarks. The floor is yours. If you have any.
Thank you, Christophe. I will express some thoughts tomorrow when I get a bit of a better introduction. I'm really thankful that I was able to join this, and thankful for the explanations, Vijay. It sets the tone, but I will express my thoughts tomorrow if that's okay.
Yeah, okay, no problem, Anthony. It's we can. I mean, if there is absolutely no remark, feedbacks, or whatever, we can just show you again the main the main web page of the main functionalities. But I'm just waiting if there are any remarks or if you have any feedbacks regarding the datasets. I don't know if you if other RCCs users you try the different functionalities introduced last week. Or it could be also the topic of these questions.
Yeah, Cedric, I just saw your message. Sorry, I stopped in the between, but I didn't see your message before. Okay, I hope it's.
No, but it's fine.
So I already
the topic of the meeting tomorrow.
Mm-hmm.
Anything regarding the Jupyter Notebook or the main functionality of the climate station? Any specific requests? Anything? If not, or you can ask in French or in English. I can translate. So, si vous avez des questions, des remarques, des suggestions pour le développement de la station climatique, si vous avez essayé de l'utiliser ces derniers jours et que vous avez vous voulez nous faire part de certaines choses, n'hésitez pas, soit dans le chat, soit en prenant la parole. And I will translate. Et je traduirai. If not, it means that we're pretty clear to explain you all the functionalities, so it's a good thing. Don't hesitate to contact us. If you have any question, you can also contact us by email. Yeah, it's fine. The next meeting will be still, if you have any question, you can ask in the chat or open the mic. The next meeting will be in about 2 weeks. The topic, we are not sure about the topic. It could be either the data set or to introduce you one data set that is available into the climate station, which is the forecast of wet and dry spells, derived from the seasonal forecast of ECMWF. Or that could be the update of the climate station. So it's not, we are not 100% sure now what will be the topic, but we will communicate you at the beginning of the week in 2 weeks. If there is no other comments, I will stop now the meeting, and I will wish you a very good afternoon or good day, and see you in about 2 weeks. Ahmed.
Thank you.
Bye. Okay, thank you, and see you very soon.
Bye.
Bye.
Bye.